beta lesson for 5-2. And in the textbook, I'm looking at example 3. We're on page 280, and it says, revisit the train problem. So the train is moving at 75 miles per hour for 2 hours, from 7 a.m. to 9 a.m., and you want the distance. Well, distance equals rate times time. So 75 times 2, it would have covered 150 miles. Okay. But it's moving at a constant rate. And the issue is they want you to write this with integral notation. Okay, so here is the integral below the picture of the graph. You're evaluating this from 7 to 9, where 7 is your A and 9 is your B. They're your inputs. And you're taking the sum of the height times the width. So the height of this rectangle is a constant. It's 75. The width would be dt, the change in time. So you can imagine these thin rectangles. They're all stacked vertically, and they're dt wide. So the width is going to 0. Okay, so you have, you're adding up all these rectangles, and you're getting the height, 75, times the width, which is how wide this thing is, which is 9 take away 7. So there's the 150 miles that this train will have covered in 2 hours. Okay, so the problem's a little simplistic, but it's helping you identify to match the notation with the question, right? And then all we're doing moving forward is finding the area of more challenging, the area under more challenging functions. So you need your calculator, and we're going to go here. For 4A. So in 4A, it says use this function on your calculator, right? Use the integration function, which is here. You go to Math 9. Okay. So I went to Math 9. You can do this, ready? I put this in Y1. X sine X. There's no point in just doing, all 3 of these. I'm on page 281. Like we can communicate to you how to use the technology with just 4A. So the limits will go from -1 to 2. We want the area under X sine X. So when you type this, when you type Math 9, this is the old school way of doing this, where you have to remember what the prompts are. If you have a newer calculator, I go here on the calculator, I type 9, it's, you're getting the prompts, lower limit, upper limit, the function, and the variable. If you have an older calculator, this is what you're going to see. So you're going to have to remember what the inputs are. So it's not really going in the same order. With the newer calculator, you're putting the limits in first, and the older calculator, you're putting them in last, the older operating system. So we're going to go Math 9. Now, when I put Y1 here, you have to put that function of Y1 first. If you choose not to, you can just type the function, X times sine X, comma the variable. Well, in the newer calculator, that's where you would write dx. And then left bound, right bound, right? And it spits out this answer, okay? Now, in the textbook, this is kind of sloppy because their answer, they rounded 2 places, 2 400ths, which, ready? It should be 2 43 thousandths because you're asked to take things in 3 decimal places in May to get full credit. And I drew the picture and shaded in what the area is, which you don't need to know how to do. I'm just saying, use the shade function on the calculator and go from the x-axis up to y1 between those 2 values. That's what's being asked. Okay. So all this is you using the technology to find the exact, as it were, area under the curve. It's considered exact if you take the 3 decimal places. So the first half of 5.2 was how to write the question. And now you're using technology to approximate the area under the curve. Okay. So we're going to pause this. Like I said, you have to have your calculator ready, and you're going to, so all you have is this. Right, I didn't draw the picture this time. The area, this curve, x divided by x squared plus 4 from 0 to 5 would be 991 thousandths. It's x divided by x squared plus 4. You're looking at that area under the curve, ready, from 0 to 5. We're saying it's a little under 1, from 0 to 5. Okay. So next thing is to go to a non-calculator perspective on this, and that's in example 5. So what if we want to integrate something that's discontinuous? And they're saying, find the area from -1 to 2 of the absolute value of x divided by x. So think about this. The numerator is going to have no sign. So the fraction is going to take on the SIGN of whatever the denominator is. So when the denominator is negative, the area is going to be negative. When you go to the right, the area is going to be positive. So you break this down into 2 separate rectangles. And this would be a question, right, that you would be expected to do without a calculator. So I say, okay, I'm going to break this down. From -1 to 2, the question, I'm going to break that down for where it is in the third quadrant, from -1 to 0, plus where it is in the first quadrant, from 0 to 2. And the area over here from -1 to 0 is below the x-axis, so that's negative. That'll be a square. That's -1. And the area in the first quadrant would be a rectangle. That would be 2. So the net area would be 1. Okay? So that's your model, and you're going to problem number 37, please. So for 37, here's what the picture is. So the discontinuity happens at 0. So you break it down into 2 integrals. Ready? From -2 to 0, the area is -2. From 0 to 3, the area is +3. So the net area is 1. Okay? And then we already went over the question 46, or which one is not represented here. And that's the issue is that in A, the rates don't match up. Okay? So